All right, so the quiz question is as follows. B to the 5th over 2. That's a kind of a funny looking 5 there. All to the negative 2, right? Yeah. All right, so, oh yeah, just in my mind. All right, so like that, right? All right, so let's talk about it. What's the rule? There's a lot of rules, huh? What did we learn about powers, this power here? Powers outside parentheses. Remember that? We had a rule for that. What do powers outside parentheses do? Yeah, they multiply. Good, I like the way you're saying that. So if you're saying they just multiply the stuff on the inside, that's not quite accurate enough. But if you're saying, like she's saying up here, they multiply the powers on the inside, then you've got it. You got to be more focused. It's not just they multiply any old thing on the inside. They don't. They multiply powers inside. They multiply. Now, is this 2 here? Is he a power? No. He's got a 1 power. That negative 2 is going to go boom, boom. It won't multiply the 2 in the bottom. It'll multiply the 2's power. So remember, powers outside parentheses multiply powers. Powers with powers. You ever been to lunch with a politician? Like a governor? The governor came here. Governor Brown, was it 2 years ago? Yeah, you guys hear when that happened, Jerry Brown? A year ago? No, 2. It was like 2 years ago. Maybe you guys weren't here then. I was here. I've always been here. Yeah, I said, Jerry, you wanted to, he didn't, no. My point in this little story is that, no, I'm not an important person in the world, and politicians never have me for lunch. Power, I'm just trying to do something to help you remember this. Power with power. Governors go to lunch with senators and people like that, right? Powers with powers, not with base folks like me, and maybe you too, right? Powers with powers, trying to help you remember that. Powers interact with powers. You know what I wanted to do that day, Jerry Brown? He was right outside this building, giving a speech right outside the OAB building, like 2 years ago. It's out there, you know, and there's a small crowd. He was giving a speech about something, I can't remember what. And obviously it was gripping too. But I was walking by and I said, oh, it's interesting. The governor's here, you know. So there's a fair big crowd, you know. And I always think it's funny. I was just coming between classes, and you see all the guys standing around with the suits on, with the little wires in their ears, you know, the protection people, right? And I just thought, I don't know, maybe I'm just twisted. It would have been so funny just to pull out a plastic gun at that point. No, of course, they would have thrown me to the ground. That would have been the end of, I would have been in jail at the end of my career, or shot me. But still, it just would have been entertaining. The speech was kind of boring, you know. I'm just twisted, I guess. I didn't try it, knowing I didn't want to be thrown to the ground or shot. So, anyway. All right, so powers multiply powers. Like that. That's the first step. Does that make sense? Powers with powers, right? Power people go to lunch with power people. Powers with powers. And then, yeah, the negative powers are unhappy. Remember, they're negative where they're at. They're unhappy. They want to jump. That guy goes down. That guy goes up. And then the powers become positive or regular. You know, you don't need to put those pluses. It's just regular. Like that. Does that make sense? We can't subtract because the bases are different. If they were both B or both 2, we would. But if they're different, we just leave them. So that's the answer, or you could say that's 4 over B to the 10th. It's the same either way. I don't remember which way it had it on the thing. Oh, it was none of the above. Yeah, it just wasn't even there. If you go back to the thing here, I'll show you it. It wasn't even there.
I didn't even notice the E, or what it was that.
Yeah, it's how you do it. Those on the bottom.
Uh-huh. We shouldn't be grabbing those other answers. Questions on that? Does that make sense? Remember the power rules then? Powers with powers. Powers outside multiply powers inside.
So the exponents always want to be positive.
And then they want to be positive. So if where they're at is negative, they're going to jump to the other side.
And you have the automatically similar to 1 right there.
Yeah, good point. Every item that doesn't have a power has an invisible 1 power, really. Exactly right. Good. Powers with powers. Good on that? Any other questions? Is that all good?
Yeah.
All right. Okay, so evaluate the polynomial. So we have minus 5x plus 6, and they want me to take x as negative 2, and what am I going to do with it? gonna plug that in. Does that make sense? Just stick it in for x. That's what evaluate means, find the value. So just plug it in there. Two negatives, multiply to be positive 10, add them up, 16. You didn't need me to show you that. See, it's the easy section. You already knew how to do that. Just plug it in, work it out. That good? Before I found something interesting. Okay, try that one. Combine like terms, collect like terms. You know how to do that, right? Same power stuff with same power stuff. Everybody get the test, the yellow or blue test. Is it a yellow packet? Make it around. Where's the extra yellow file? Over there. So they're up here if anybody needs them. The extras. All right, so the 6b to the 5th and the minus 4b to the 5th. You just do the numbers in the front, huh? 6b to the 5ths minus 4b to the 5ths is 2b to the 5ths. Just subtract the numbers in the front. And then the other two, 3b squared minus 3b squared, that's just gone, huh? They just cancel, don't they? So that's our answer, just the 2b to the 5th. Is that good? Collecting like terms? Yeah, because it's 3 minus 3. It's 3 of them minus 3 of them. 3b to the 5th, or b squared minus 3b squared. So 0. 0b squared. So go on. Good? Questions on that? All right. All right, so try that one. Same kind of thing, like terms with like terms. Okay, that minus x to the 4th, he's got no number in the front, so what number's really in the front? It's really a 1. I'll just put a minus 1 there. Minus 1. So it doesn't matter what order you do them in. Any order is fine. I'll just start with 7x squared minus 3x squared minus 4x squared. You just do all the x squareds together, right? All the numbers in the front. So 7 minus 3 is, oh, it's going to be 0 again on the x squared? Yeah, the x squareds just drop out, don't they? Because there's 7x squared minus 3 is 4. Minus 4 is gone. 0. 0 x squareds. No x squareds left. But we do have 9x to the 4th minus 1x to the 4th. So that leaves 8x to the 4th. And that's all.
What is negative x squared here?
Yeah, the total just is 0. So we have 7x squared minus 3x squared. So 7 minus 3 is 4. And then at the very back, they take that 4 away, so there's none. No x squared if you want, but 0 times anything is just 0, huh? Makes sense? So it just vanishes. Questions on that one? All right, so we just do the different powers separately. We call those like terms, right? X squareds with x squareds, they're like, and x to the 4ths with x to the 4ths, they're like. Good question, Martha? Oh, good question. We're not. I'm not adding the powers. No, I didn't go 4, 4, 8. Why not? There is a time we do that. When do we do that? Does anybody know? When you multiply. We're going to get there in a few minutes. Good question. Yeah, if these were times, you would add the powers. But if they're just adding, subtracting, you don't mess with the powers. You only do the numbers front. Let me write that note. So it's a good question. When adding and subtracting, only add, subtract numbers in the front, not the powers. Yeah, it's multiplying when you start messing around with the powers, which we'll do in just a few minutes. Yeah, good question. All right, good. Is that good? I flash that off. So, which should probably be easy. Okay, so basically they're going to say, hey, is this a is it a trinomial, monomial, binomial, or none of the above? Yeah, you just simply count them. 3 terms? Trinomial, huh? A, 3 terms. Trinomial. Easy enough on that. Tricky. Yeah, so 45x. The question is that 2 things or is that 1 thing? Well, the way we think about it, I mean, you could make an argument either way. You could maybe say it's 3 things. I don't know. But anyway, it's the way we're looking at things, it's 1 term. That's a monomial, and here's why. It's 1 term. Because we mean that terms are separated from each other by pluses and minuses. So like if there was a plus 17, or even if it was 45 plus x, you know, that would be 2 terms. Yeah, let me leave that up there. That would be helpful. If we had 45 plus, if we had that, that would be 2 terms. But if you just have 45x, it's only 1 term. It's a monomial because there's no separation between them. Does that make sense? So the pluses and the minuses are the separators. So 45x has no separator. That's just 1 thing, 1 term. But 45 plus x, that would be 2 terms. That'd be a binomial, yeah. Everybody good with that? So the separators are the pluses and the minuses. For sure. All right. So 3/8 minus 2/5. Let me see what you remember. I'll give you a second. See if you can subtract those. You have a nice enough calculator, it'll just handle it straight. The old Casio natural display will just do it straight. Remember how you have to multiply by the other denominator? Remember how that works? So like the first one, you got to multiply by the 5 because that's the other denominator, and the other one by 8 because that's the other denominator. Make both of them 40 on the bottom like that. Remember all that kind of stuff. Good. Yeah, you do. Good question. Well, I guess it just, yeah, so is that good so far to there? That's, I guess it's just going to be -1, so there's really no reduction needed, huh? 15 minus 16 is just -1. Is that good? Questions on that one? Okay, yeah. So C equals, whoops, xm plus x. Solve for m. So it's like there's a wall here, and m is saying, I want to be alone, you know? You're supposed to solve for m. So what can you do to solve for m? Let me let you try something. So what's the first step? M's right here. He said, I want to be alone. Get rid of these x's, right? So I can be alone. Yeah, we always do the adding, subtracting. We save the item right next to m, or whatever letter, for last, and divide. Huh? Yeah, good. So the first thing will be just subtracting x, huh? Boom, like that. Then we get c minus x. Whoops, yep, I'm writing it backwards. Yeah. Exactly, and then the last step is always divide. Divide by the x, boom. There it is.
So,
Question?
I tried to enter that in on Math Excel, but it said the format isn't right.
Well, I'll come by and look in a minute. Good question. Yeah, can those x's cancel? It's actually a no. We're going to be getting into that in days to come, but let me just mention for now. Pluses and minuses kind of like glue things together. I might have said it once, I can't remember. They glue things together so you cannot cancel those. They're like stuck. In other words, the only way you can cancel is if, when you have c minus x over x. The only way this c and this, they're saying we're glued together. In other words, you can't. The only way you can cancel anything up there is if you take the whole thing or nothing. You can't take part of it because it's a glued package. Pluses and minuses, connect things, glue things, to where you buy the whole package or you buy none of it. It's all or nothing for a glued package. So because of that, we have to take nothing, because we can't take just the x. So anyway, so it just stays right there. That's the final answer. No further simplification is possible.
Okay, it's just the capitalization.
Oh yeah,
You
it's
don't
picky.
capitalize the stupid verb.
Yeah, it is. Math Excel is picky on the case here. Notice that C is uppercase and the X's are lowercase. So yeah, it gets picky. That's right. Okay, 72R plus 63S plus 45. All right, what do they mean when they say factor? Now, there's all these math words, and it's hard to remember what do they want me to do? Yeah, they want you to like do a parenthesis, like something on the outside and like 3 things on the inside, so that if it was to multiply, it would go back and be the same thing. Yeah, factor basically means unmultiply. Like, show me what it was before it was multiplied. Yeah, so try that. Use your calculator if you need for those kind of big numbers. So use your calculator. What goes into these 3? Try dividing different things, you know.
Oh, what is it, what multiplies to 63 and adds to 45?
Oh, no, that's harder factoring. We'll do that later.
Oh.
Yeah, we'll get there. No, this is just simply, what number divides into all 3 of those? Yeah, so 9 is what you want, huh?
Yeah.
They're all divisible by 9. And then you just ask yourself, okay, 9 times what? We'll go back to 72R. 8R, yeah, just take 72 divided by 9 on your calculator. Divide each of these by 9. And it'll tell you what to do. 7S, and this one is what, 5? And that's it.
Well, there's a way I figured out how it's 9. Is I actually added the numbers. So 7
Yeah.
is 9, 6 plus 3 is 9.
Have you heard of that trick? Carice, right? Carice is right. There's a trick that is for 9 and for 3 as well. If you add the digits, 7 plus 2 is 9. That means 72 is divisible by 9. 6 and 3 add up to 9. Divisible by 9. 4 and 5 add up to 9. Yeah. The number adds up to 9 or anything divisible by 9, then the entire number is. It's a little trick come in handy. But you got a calculator. You can just check it that way too. Questions on that? We good? Question?
Is there any way that you can go back and do that fraction one?
Yeah, we probably will. If there's not another fraction one, we'll go back and do that one.
Okay.
We'll do some kind of fraction one for sure. All right, so what do you do with that minus that's in the front there? Yeah, it's a -1, if that helps you. It's a -1. And then what does that -1 do? Distributes, exactly. So go ahead and distribute it all the way through. All the way through there. Like that. Is that good? So it gets minus 12x to the 4th plus 2x to the 3rd minus 4. Is that good? Questions on that? Easy? You guys are looking at me like, we got it, Miss Taryn. Move along. All right. All right, so try that one. So 8x plus 5 minus 6x plus 8. Yeah. All right, you guys probably know the first step. What do we do with that minus sign that's in the middle, I mean? Where's he going to go? It's going to go boom and boom, huh? It's really -1 if that helps you. It's going to, so first do that. Now notice there's nothing in front of the first parenthesis, so you can just drop them. It's no big deal at all. But the second parenthesis, the minus is going to go through, right? I think you all know all this already. Right, so that'd be a plus 6x and a minus 8. Is that making sense? Good to there. So far, I mean? So does everybody understand? So what a good question I often get is, well, how do you know like when the parentheses drop or don't drop? The main thing with the parentheses is when you drop them, which you should drop them, you know, anything in the front that's like waiting out there is going to go in. Does that make sense? So you see how with the first, you know, so I think it's like dropping a wall that has like a dam floodgate, right? It has water up against the dam wall. When the wall comes down, the water rushes in, right? That's kind of like what it is. So this minus sign is like water waiting up against that wall. So when the walls drop, it rushes in and hits everybody. But there's nothing in front of this wall. So they just drop and nothing changes, right? On that. So that's what always happens. And then we have to do one more step, don't we? We have to combine like terms. So 8x and 6x, 14x, and then 5 minus 8 minus 3. Good to there. So we're done with that one. All right. Whoops. Okay, so there it is. So it's going to be 1. I'm just going to drop the parentheses right away. 1.6x to the third plus 4.4x squared minus 3.8x. And then this minus sign is going to go boom, 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 huh? Plus 4.8x cubed plus 4.7x squared minus 35. We good to there? So I dropped all the parentheses, right? Whenever the wall comes down, the water rushes in. Anything that was in front of the wall, in front of the parentheses, goes in and hits everybody. And now, just combine like terms. Use your calculator. 1.6. I would just take my calculator and go 1.6 plus 4.8. What is that? 6.4 x cubed. That's a 3 there. Yeah. It's a weird looking 3. Good for that one. And then x squared and x squared. So 4.4. So what was that? 9.1? I don't think so. Isn't it 9.1? 9.1. And then what else? And then just minus. Then the other two don't combine, do they? Just minus 3.8x and minus 35. They're unlike, and so that's just it right there, huh? Is that okay? So we just combine the like terms, use your calculator, just add or subtract the numbers in the front. Again, there's no messing with powers yet, huh? Because we're not multiplying any letter expressions yet. Yeah, we're just adding, subtracting. So when you're just adding, subtracting, you just do the numbers in the front. You don't mess with powers. But when you're multiplying a couple of things that have letters, that's when the powers start to add.
So the reason you don't add 1.6x is it because it doesn't have an exponent? Is that why you don't do that, like add back terms with that one? With the 3.8x? You just run it down?
So what did you say? Why I didn't add 1.6 with 3.8?
And 4.7, because they're all like terms that have an x on it.
Yeah, so only the ones that have x's to the same powers.
Oh, okay.
Am I making sense? Those are the like ones. Yeah, it's just the ones that have. Yeah, so that's why I did. Let me change my color here. That's why I did this one with this one, because they both are x to the thirds. So just add their numbers. Does that make sense? Just this one with this one, because they're both the same power. So I just add their numbers in the front. And then both the x squareds. Yeah, so just we call that like terms. The ones that have the same powers, add their numbers in the front. All right. Okay. So we have, I'll bring it over here, 6x to the fourth plus 2x cubed minus 6x squared. And then that minus sign, it's going to do what? It's going to distribute, 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 distribute. So I actually get a plus 2x to the fourth plus 5x cubed minus 7x minus 6. That makes sense what happened there?
Start over.
So a minus sign that's in front of parentheses will just always hit everybody in the parentheses, changing all the signs right down the line. So that's what always happens when something's up against a parenthesis wall. A number or a minus sign, it just like dominoes, just distributes in, hitting everybody inside the parentheses.
Why does it look like that? Like, why is there a line or something?
Oh yeah, they're just doing it vertical, like one on top of the other instead of side by side.
Are you gonna have it on the message?
No. Yeah, I just put them side by side. But some people like it better, stack vertically. If you want to, you write them that way. I mean, but yeah, does that make sense what I did there? So we're not done yet. We have one more step, right? But all I did is I just took a minus in front of parentheses and let it distribute through. That's what a minus sign always does when it's in front of parentheses. And now, just combine them vertically. So 6x to the fourth and 2x to the fourth. 8x to the fourth. I don't mess with the powers, do I? Because we're not multiplying, we're just adding and subtracting, right? So just the numbers in the front. Don't mess with the powers unless you're multiplying. And then the next one, 5 and 2 is 7, x to the third. And all the rest are just going to drop down, huh? So minus 6x squared minus 7x minus 6. And there we go. Is that good? Questions on that? We happy? All right, that's an ugly mess. All right, so 1/8 x to the fourth. Hey, by the way, before I go further, what's in front of the parentheses? Are there any minus signs in front of any parentheses? No. Then you can just drop the parentheses. They're doing nothing. Everybody see that? Yep. So remember, the only time you have to worry about parentheses is if there's something right up against a negative sign or a number right up against the parenthesis wall. Then when you drop it, it's got to hit, got to distribute to everybody inside. Huh? But in this case, there's nothing, there's only a plus sign in front of the second parenthesis, and there's nothing in front of the first parenthesis. Right? There's not even a plus sign out here. There's nothing. So anyway, the parentheses are unimportant. They're really just decoration. Just drop them. So I'll just drop them. I'm going to rewrite everything with no parentheses. So there's the first one. And then the second one is minus 5/8 x to the fourth plus 7/8 x squared. So there's the first one and the second one. Are we good to there? It was really plus a negative, but you know plus a negative is just negative, huh? So I just wrote minus. Okay, now we can combine like terms, huh? So so we're going to do the ones that have the same powers together. We call those like terms. So the ones that have the same powers we do together, and we just do the numbers in the front. We don't mess with powers because that's only one multiply. Oops. Oops, I'm getting it all messed up here. All right. So 1/8 x to the fourth minus 5/8 x to the fourth. So what's that going to do? Negative 4/8 x to the fourth. Good so far? right? So the 1/8 x to the 4th minus the 5. 1 minus 5. You just do the numbers in the top, huh? When you do fractions, you just subtract the tops. So 1 take away 5 is -4. Food in class is fine as long as it's not too distracting. Bananas are great. They're really quiet. No, that's fine. Just please don't make a lot of noise. It's all good. Unless you want to share with the teacher. I'm always hungry around this time myself. All right. 7/8 x cubed and, oh, I was going to circle that one. That's not right. It's by itself, isn't it? So, yeah. So that would be just all by itself. 7/8 x cubed. All right. And then we'll go on to the x squared. 1/8 x squared and, oh, yeah. Another 1/8 x squared.
Would that be 1x squared?
Oh, is that a 7 and I just erased it? Yeah, thank you. Thank you. So that's 8/8, 1. Yeah, originally it was right here, and I just kind of copied it wrong. Yeah, so 1/8 and 7/8 is 8/8 is 1, huh? Is everybody good with that? Yeah, exactly. Let me write that up here. 1/8 and 7/8 is 8/8 or 1 x squared.
And the negative and positive 4 is 0.
Yeah, the plus 4 and the minus 4 is just gone. It's just 0. Is that okay? Question?
4/8.
Oh, you're right. You're right. I forgot I got to reduce that 4/8, huh? I got to make that a half. That's right. Anytime fractions are reducible, good job. I forgot. We have to do that. Yeah. Math Excel will throw a fit and not give us credit unless we do that. Yeah, thank you. So that 4/8 becomes a half. So there we go. We did the fraction one. They're always a little painful. Is that okay? Guys happy with this section? Question, Martha? Good? No? Roberto's going to sneak out the side door, but I always call attention to him, so he can't ever sneak out. He's our class tutor. Come see him. If you need help, he's glad to help. Roberto, they keep erasing your hours in here, huh?
Yeah, you want me to write it down again?
Would you mind?
I'll write it here.
Yeah, try there, maybe. And could you write please save?
Sure.
Or else? Or no, just don't. Just write please save, probably.
Or Mr. Heron will buy.
Yeah. Don't mention Mr. Aaron. I have no power, but sign it the president of the school or something. Okay, so 4x to the 4th, 5x to the 6th. Okay, so now we're multiplying, huh? Notice we've changed gears. We're not adding or subtracting anymore. We're multiplying. Okay, so let me write the rules for that. So when you're multiplying, what do? Number 1, you multiply the numbers in the front. Whoops, I'm kind of scribbling here. And you add the powers, exactly. Well, you add powers on same letters. Yeah, which we know.
Same base.
Yeah, right. So multiply the numbers in the front, add the powers. Yeah, so that's different, huh? Than we were adding. In fact, maybe if I write both sets of rules up, it would be helpful. So that's one thing. When you're adding, subtracting, like we were just doing, you only add or subtract the numbers in the front. So that's what we just finished. When you're adding or subtracting, you don't mess with the powers, not powers, right? So we were just doing a bunch. We just finished 2 whole sections of adding and subtracting, and that's just the numbers in the front. We don't mess with powers. But now we're going into multiplying. We're timesing these things. And so we multiply the numbers in the front and add the powers.
If the numbers in the front were to be the same, you
You still do. Yeah, even if they're the same. Well, you have to multiply those numbers in the front. Yeah, so 4 times 5 is 20, and the 4 and the 6 add to be 10. Like that. You know what you might be thinking of? Let me answer your question more thoroughly. You might be thinking, hey, like what if they have 2 to the 6th times 2 to the 7th? Yeah, we don't multiply those 2's. That would just be 2 to the 13th. But that's not what I'm talking about, you see, because those are the bases, right? That the powers added, you don't actually multiply the bases. I'm talking about when you have, see how this 4 right here? He doesn't have the power on him, does he? It's not 4 to the 4th. He's just next to something with a power. So I'm saying we multiply the numbers, they're called coefficients, like a co-pilot. It's just somebody with them. So the coefficients, the 4 and the 5, they're just the numbers next to the bases. They multiply. Thanks, Roberto. All right, we all good there? Does that make sense? So you just multiply the numbers in the front, add the powers. All right. No questions, all good. All right, so negative 1/3 x to the 6th and negative 1/8 x. All right, so same thing, give that a try. Multiply the numbers in the front, add the powers. Hey, what power does that second x have? 1, huh? Yeah, remember how we talked about that? When there's no power showing, there's really a 1 there. Huh? So multiply the numbers in the front, add the powers. So what is negative? 2 negatives? Negative times negative? Positive. And then you just go top times top. 1 times 1 is 1. 3 times 8 is 24. So far, so good. Just multiply top times top and bottom times bottom. 2 negatives makes positive. And then we add the powers to the 7th, huh? 6 and 1 makes 7. That good?
You don't need to have a common denominator for those?
Yeah, good. You don't. Good question, though. Yeah, why don't we need common denominator? And there are times we do. When do we need common denominators? When you're adding or subtracting. Yeah. Yeah, if we were adding, so when you add, let me write that. It's a good question. When you add or subtract fractions, you need a common denom. Yeah, it's only adding or subtracting. Basically, you'll notice in algebra, everything hard is adding, subtracting. It's kind of funny. Everything that we do. And that's the opposite of when you first were in school, right? You learned when you were a kid, the first thing you learned was to add and subtract. That was pretty easy. And then multiplying was harder, right? Dividing was harder. But it's reversed in algebra. The hard parts are adding. Like, think about fractions. It's much harder to add a half and a third, right? You got to make the bottom same and fiddle around, all that kind of stuff. Whereas if you're just timesing them, that's easy. It's 1/6, huh? Yeah, and that goes for everything we do. Multiplying is always easier. Adding, subtracting is the harder rules in algebra. All right.
Multiplication and division?
Yeah, multiplying and dividing always go together. They always have very same kind of rules. All right, try that one. 4x to the, was that 8? Minus 5x to the 5th. 8x to the 5th. If you can read my scribble in there. Okay, so multiply, you can use a calculator if you want. Multiply all those numbers in the front and add all those powers, right? So 5 there. So you add the powers. Was that 18? And then you multiply 20, negative 160. It's negative because there's one negative. If there was 2 negatives, it'd be positive, right? And so there we go. Good? Questions? Are you happy? All right. Am I going too quick? We'll move it. Okay, so try that one. Minus 2x. X minus 2. So what's needed on that one? Distribute, huh? That minus 2x is going to go boom and boom. And every time you multiply, what's the rule? Multiply the numbers in the front, add the powers. What powers? What powers are really there when there's no power shown? Invisible ones, huh? Yeah, so that'll probably help you. Put the invisible ones on those x's. So multiply the numbers in the front, add the powers. So minus 2x squared plus 4x. Not good. The two negatives make positive there at the back end. Good enough. So multiply the numbers in the front, add the powers. All right. Let's try that one. So 2y to the 4th and 8y to the 7th plus 3y to the 6th. So same thing, right? Going to distribute. Boom and a boom. Multiply the numbers in the front, add the powers. Okay, so 2y to the 4th and 8y to the 7th. 2 times 8, multiply the numbers in the front. 2 times 8, 16. Y to the 11th. Add the powers. Plus, good so far. And now this guy goes to this guy. Multiply the numbers in the front. 2 times 3 is 6. Add the powers. 4 and 6, 10. And there we go. Good? Easy so far? I'm going to probably make it a little bigger in a minute. So make sure you're comfortable with these Yeah, first outer, inner, last. Yeah, exactly. That's right. We're going to be having a lot of being foiled. All right, yeah. So I'll present it two different ways, whatever way you like. Yeah, the FOIL way, or I'll just say first above, second above, basically. Right, so we have two things multiplying two things. Okay.
Over, under.
Yeah, over, under, that works too. Yeah. So yeah, so there's different ways. Here's one way is you could just say, look, this first one has to go to both those guys. Right? And then when he's done, then the 7's going to have his turn to go to both of them. It's going to be 4 multiplications. The first is going to go to both the other two, and then the second is going to go to both the other two. So that's how I think about it. It's just first to both, second to both. You know what I mean? Like if I didn't even have the 7, let's suppose he wasn't even there, then that x would just distribute and we'd be done, huh? But I do have the 7. And if I didn't have the x and I just had the 7, what would he do? He would distribute. So really it's just double distribution. I have them both, so they both take a turn distributing. All right. So and when it happens, you know how it works, right? Out front numbers multiply, powers add. What powers? The x's have understood invisible 1 powers, huh? All right, here we go. X to the 1 times x to the 1. X to powers add, right? When you multiply, powers add. And then x to the 1 times... Now remember that sign. A lot of people get confused with the signs. Let me do something to help with those signs. That is my job, to help here. Put that right on the ones they're in front of. And I think that'll make it real clear where they go and what they do. Does that make sense? Anytime you get like a minus or a plus or whatever that's in front of somebody, it's really his. Wherever he may go, that's his, right? He doesn't want to leave that behind. So that plus x goes to the minus 2, minus 2x. So he's done. He had his turn. That x went to both the 2 in the other parenthesis. He's done. His turn's over. Now the plus 7 is going to go to both. Here we go. plus 7x minus 14. It's positive 7 times negative 2. Now we have one more step, don't we? Because we got to combine the like terms in the middle. Was everybody good to there for starters? That's also called by the name FOIL, which is another good way, whichever way you prefer or are used to. FOIL stands for first, outer, inner, last. And that's exactly what we just did if you think about it. When it says first or front, some people say front, either way, it means the first one in this parenthesis times the first one in that parenthesis, which is exactly what we did to get x squared. And outer means the two outer ones, which is exactly what we did to get minus 2x, huh? And I stands for the two inner ones, which is 7x, which is exactly what we got. And L stands for the last times the last, which makes negative 14, which is exactly what we did. So we just did FOIL without saying it. First to both, second to both is the same as FOIL. Whichever is easier for you to think about. Now, we do have one more step. By the way, multiplying is over now. Let me just write that. Multiplying is over. Now, add, subtract. You with me? Because how do I know? Well, the parentheses are gone, aren't they? There's no more parentheses, so there's no more multiplying. Now I'm changing modes. Now I'm in the adding, subtracting mode, right? So I'll combine these two, and I'll just do the numbers in the front. I won't mess with powers, because multiplying's over. So x squared, 7x minus 2x, 5x, and bring down the 14, and we're done.
Can you go back to number 7?
Sure. Everybody good with that one? That makes sense. So first to both, second to both, and you drop the parentheses, right? Because that's what happens when you multiply it. Parentheses drop off, and then you combine the middle two, like that. You can only add or subtract like powers, huh? Like terms. But you can multiply anything. Has everybody seen that difference? Right? So, like back on this problem here, if it was 16y to the 11th times 6, if it was times, I could totally do it. You don't even give a thought to like terms. You just do it, right? Front numbers multiply, powers add, do it. We don't care whether they're the same or not. But for adding, subtracting, it's picky. See, I was saying adding, subtracting is always more difficult. It's picky. Just like for fractions, you got to have common denominators. For letters, you got to have same powers, or you can't add them. So that's why we don't do that. Yeah, good question. All right, so number 10, let's try this one. 2x plus 5 and 2x plus 5. Try that one. So first to both, second to both, or FOIL. It's going to be 4 multiplications. Okay, you doing okay? Feel free to check, during these, feel free to compare with those around you. As much as you can out of these 2 hours. Okay, so 2x with 2x. Remember how it works? Out front numbers multiply, powers add. What powers? The invisible 1 powers, huh? So 2 times 2 is 4, x squared. Plus 2x times 5 is 10x. He's done. That first one went to both, right? First to both. He's distributed, he's turns over. Now the 5 is going to go to both. 10x, and 5 times 5, 25. So now the multiplying's over. There's no more parentheses. We're all done multiplying. Now we go into adding, subtracting mode, which means only like terms. Only like terms. The 10x and 10x in the middle. 20x, and we're done. So our answer on that one. Is that good? questions on that one?
So it won't be 20x to the second, even though you.
Yeah, good question. Why isn't it, guys? Did I forget 1 power, 2 power? No, that's not right. Why not? Because we're not multiplying. That's only if that was 10x times 10x, I would add the powers. But if it's not, you don't mess with powers. Remember, when you're adding, you don't mess with powers. You only do the powers when you're multiplying. Good question. Everybody good? This rule's all coming together for you? All right. Whenever you get decimals, just use a calculator. So x minus 3.3, x plus 3.1. Try that one, foil that one. First to both, second to both. So this first one goes to both. X squared, right, because the understood invisible 1 powers add. Right, when you're multiplying, powers add. Plus 3.1x. He's done. He went to both. Now remember those signs, whoever they're in front of, that's who they're really with. Right? So if it helps you, let me just move these signs. That minus is really on the 3.3, and the plus is really on the 3.1, right? So that minus 3.3, that negative is going to go with that 3.3 wherever it goes, right? It's stuck on him. It's glued on him. So minus 3.3x. And then negative, I don't know. Which calculator say? 3.3 times 3.1? 10.23? Is that good? Just use calculator on that. See why it's negative? Because negative times positive. We have one more step, but is everybody okay to there? See what happens. So make sure you know those signs. Whoever they're in front of, that's who they go with, right? All right, then right in the middle, 3.1 minus 3.3. What's that? Minus 0.2x? Whoops, that's a scribbly looking 3. Everybody good with that? Plus 3.1 minus 3.3 is minus 0.2. Now we don't mess with powers, right? We only mess with powers when we're multiplying. And so that's our answer. Questions?
So on here, because it's five, well, mine was 5.46 on here.
Okay.
It says that you have to put the other two after that. Math Excel. Two. Because it's 5, like my answer, I'm doing my homework.
Right.
So it's 5.46, so on Math Excel, it wants you to put like the 5.46. Because I just put 5.4 and didn't put the.
I'll come by and look. Let's see. So they want you to find the area. Remember how to find the area? Do you know how to find the area? Like if you want to find the area in this room, if they wanted new flooring. They want to go to the store and buy new flooring. How much flooring would they need? How would they figure out the area in the middle of the room? Yeah, one side times the other. It's a big rectangle. Huh? Just whatever you call it, length and width, height and base, whatever you want to call it. Just one side times the other. So that's what we got to do here. One side times the other. So how this side is t plus 3, and this side is 4 plus t. Or I could write it t plus 4 if that's easier. Does that make sense? Right? Because it's, this part is 4 long, this part is t long, this part is t long, this part is 3. Okay, so the area of this shape then, is what they're saying, find total area, is one side times, parentheses, times the other side. Is that good? One side times the other. So I'm going to FOIL that out, in other words. It's another FOIL. It's a first to both. It was just a tricky way for them to give you a FOIL question. See how it ended up being a same kind of question as all the rest?
So it's
It could be, yeah.
Oh, I already changed it.
That's
Oh,
nice.
no.
Did you draw that?
My
They
daughters,
got her, yeah.
they got a hold of it.
Yes.
No, what it was is when I was putting it into the computer, I was just putting 4.4, but it wanted me to put the 5.4, but it wanted me to put the 5.46. So if you don't put it, the extra number, 6, it's not.
Do you have your calculator? What is 1.4 times 3.9?
Well, no, plus. No, the times. Oh, yeah, so whatever, yeah.
Yeah, it was I was using it.
Oh, yeah, we're gonna put in the whole answer.
Because I just put in the 4.6.
Oh, okay.
5.4.
Gotcha. All right, so we okay with this FOIL here? We FOIL that out, t squared plus 4t. So that first one goes to both, and then the second one goes to both. That good to there? First to both, second to both. And then these two are like terms. So now we're adding now. Multiplying is over, huh? So it's not 7t squared, it's just 7t. We don't mess with powers when we're adding. And so there we go. Is that good? So that rectangle thing was just a fancy way to make a FOIL question, really. All right. All right, so they whoops. What do they want me to do here? Do they just want me to FOIL that out? Oh, they want me to fill in the boxes. All right. Yeah, let me help. All right, so basically it'd be better if they just gave us a regular question, but see how they're using like a big diagram to kind of show you the 4 parts of the FOIL? That's what they're doing. You know what I mean? Like if I was over here, let me show you the regular, and then I think, whoops, it's supposed to be 4, huh? And then I think what they're doing will be more clear. If you were just doing this problem regular, without their fancy picture, if you were just doing it regular, you would all know how to do it. The first one just goes to both. It would just be x squared plus 3x, right? And then when he's done, the 4 goes to both. And it would be 4x plus what, 12? 4 times 3, 12. Like that? Well, they're just showing you that in terms of this picture. See how we have 4 different parts? And you'd have to do one more step, combine the middle two. But see how we have 4 different parts? See how one of the parts is x squared? See, here's x squared. One of the parts is 3x. That's 3x. And the other 2 parts they want me to fill in, it's going to be these 2. See how they're doing it? See how the side is x and 4. That's the x plus 4. And the other side is x, and what should go in this box is 3. So they want you to put a 3 in that box. Do you see how we're doing that? I'm making the 2 outsides of the rectangle, x plus 4 and x plus 3, be the 2 things we're multiplying. That's the trick. They're just saying, hey, if we make the outsides of the rectangle be the 2 parenthesis things, then the 4 inside parts will be our 4 answers. They're just showing you a picture way of seeing the FOIL.
So then you take 4x and...
Yeah. So let me erase what I've got and go back and make more sense of it. Yeah, so you see on the outside, see how you have x and 4, like the first parenthesis is x and 4. So therefore, if the other parenthesis is x and 3, what do these have to be? We already have the x, so this has to be the 3. See that? That's what they want you to put in that box, is a 3. And now, okay, I see that. Okay, that's all good and everything. But now, so put the 3 back here. How do you find out, like, what goes in that box? Well, it's simply like a big multiplication table. You know what I mean? Remember the multiplication table? 1, 2, 3, 1, 2, 3, and you go, what goes here? What goes here? What goes here? What goes here, 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 here? How do you figure out? Like, what goes right here? 2 times 3, 6, right? That's what they want you to do. 3 times 4, 12. And what goes here? X times 4, 4x. That's all they're wanting you to do. Now see how those 4 parts are the 4 parts of our thing? Whoops, that was a 12. See, 3x, x squared, 12, and 4x. X squared, 3x, 4x, 12. See? It's the 4 things. So it's just a big fancy way to show you with a picture what you're doing with a FOIL. All right, so that's all they're doing on that one. Okay, so x squared plus x plus 7, x minus 7. So now they're doing a 3-termer with a 2-termer. It's getting a little bigger. How do we do that? Well, it's the same way, right? Just everybody has to multiply everybody. Yeah. So, so I'm going to start with this x squared. And remember that minus sign on the 7, just for extra clarity, I would put it right on that 7. That's his baby, right? It's right on that 7. All right, so here we go. X squared has to go to both those two. We're multiplying. So when we're multiplying, you add the powers, huh? And there's an invisible 1 there, so it's x to the 3rd minus 7x squared. He's done. Is that good to there? And then the plus x, he's going to have his turn. He's going to go to both those two. So that powers are going to, he has invisible 1 power. Powers are going to add. Plus x squared minus 7x. And then finally, last step, the 7 itself is going to go to both those two. Plus 7x minus 49. I have to do some more combining of like terms in a second. But does everybody see what happened there? So first, the x squared went to the other two, produced those 2 terms. Then the x, then the 7. I got 2 terms, 2 terms, 2 terms from the multiplying. Is that good so far? See how that happened? Now, multiplying is over. The parentheses are gone, right? So now we do add, subtract. So that means we only combine like terms, and we don't mess with powers. So x cubed, he's in a category by himself. Nobody like him. Minus 7x squared. What do we do with the minus 7x squared and the plus x squared? Those are like terms, aren't they? Same powers? What's in front of that plus x squared? 1 plus 1, huh? So minus 7 plus 1 is minus 6x squared. And we don't mess with powers, right? We're in adding, subtracting mode. We just do the numbers in the front. Now, minus 7x and plus 7x just cancel. They make 0, huh? And finally, the minus 49. There we go. It's tedious. It's the same thing. It's just a little messier. Is that good? Questions? James?
So when you're doing the FOIL, you get 3, 4, 5, whatever.
Right.
Okay, so you're only going to do the first one on top and the rest on the bottom?
You can draw it however you want. I was just, if you want to do all of them up top, I'm just showing their travel pattern. It's like a map, and I'm showing where people are going, but you can show it on the map however you want. Does that make sense? Like I could have showed the 7 going to visit the other 2 on the top by arrows on the top or arrows on the bottom.
Okay.
That's just the trip. That's just showing the trip. Doesn't matter how you show that.
Okay.
Make sense?
So as long as you do the first 2,
Yeah, so you just,
then bottom, the third one doesn't matter which way you...
none of them matter at all for anything. I'm just showing the travel pattern. I'm just saying, hey, this x squared, he's got to visit the other 2.
Mm-hmm.
I could go woo and visit. Makes sense? I'm just showing somehow he goes from where he's at to where they are.
Okay.
Doesn't matter how you show him getting there. Makes sense? Any way that's convenient for you. Yeah. I'm just trying to show that everybody has to visit everybody, basically, is the... y squared minus 7 times 5y squared minus 3y plus 3. All right, so the y squared has to visit all the other three, huh? And remember, any signs in front of a number, that's their sign. So it might help you to write that way. Let me do that too. Minus is right there. Minus is right on that 7. Plus is right on that 3. Is that good? Like that? Any sign in front of them, that's theirs. It'll go with them wherever they may go. Right? Oh, my mistake. Yeah. Yeah. Good job, good job. What power is on what power is really there with one? Yeah, put it in there. That's okay. Remember power is
The second.
the third power, right? Because the power's add, remember? Yeah, okay.
Distribute.
So now you can cross him off. He's done. Yeah. Yeah.
Thank you.
You can go either way, right to left to left to right. Gotta work either way.
So this is the one we did before, should I have started with a small one?
Yeah, I like that. I think it's easier to start with smaller.
Yeah.
You could even rearrange it right in the beginning.
I feel like I get lost.
I kind of do too. I like it to put the small one in the front. Yeah, you know, you can always rearrange these parentheses. So a good question was being asked. On the last one, with we had the 3 in the front and the 2 in the back. Sometimes I like to just slide the 2 in the front. It's easier for me to see it that way, but you can always rearrange them. It'll work out the same. Question?
On the -7,
Uh-huh.
that's going to distribute over?
Yeah, the whole -7. Yeah, so first off,
3 could, right?
so let me do the y squared first, and I'll get to the -7. Yeah, so the y squared is going to go to all 3. So it's basically everybody in the first parenthesis hits everybody in the second parenthesis. It's like the neighbors visit all the neighbors. So here we go. So y squared, y squared. Now what happens when we multiply? Out front numbers multiply, powers add. So that'll be 5y to the 4th. And now y squared is going to go to -3y. So that'll be -3y to the 3rd, because this has a 1 power on it, huh? Invisible 1 power adds to the 2. And then now y squared is going to go to the +3, plus 3y squared. And he's done. He had his turn. He went to all 3. Now, let's change gears. And now I'm going to take the -7, whoops, and he's going to go to all 3. So out front numbers multiply. So -7 times 5 is -35 y squared. Out front numbers multiply. Now -7 and -3. Positive 21y. 2 negatives make positive. Good. And then -7 times +3, -21. We good there? So far, so good? Now, the multiplying is over at this point. There's no more parentheses. So now we go into adding, subtracting. So now we're going to add, subtract, which means 2 things. Only like terms and no powers. We don't mess with the powers at all, right? So 5y to the 4th, he's category by himself. -3y cubed, there's also no other y cubes, huh? Okay. Now 3y squared minus 35y squared, what's that, -32 y squared? Those two combined. And the other ones just drop down, huh? And we're done. We good to there? Makes sense what's happening? Questions I can answer on that? Okay. All right. Okay. All right, so we have x minus a half, 2x cubed minus 4x squared plus 3x minus 2/3. Okay, so first off, the x one is going to go to all 4, isn't it? And as it multiplies, out front numbers multiply, powers add. So x times 2x cubed. 2x to the 4th, right? Because the invisible 1 power. I can't tell. Is it 19? Yeah, 19. Mhm. Good for the first 4. And now he's done. Now the minus half is going to go visit everybody in the other parenthesis. And he's just going to take half of those as he goes along, right? Half of 2, half of 4, half of 3. Now they're going to make you, well, the multiple choice options are fractions. So we get minus 1x cubed, that okay, because half of 2 is 1. Plus 2x squared. Minus 3 halves x. Did I confuse you with that one? Do you see why it's 3 halves? Because this 3 is really over 1, isn't it? So when the half, the minus half, hits the 3x, it's over 1. So the 3 stays on the top, the 2 goes to the bottom. Everybody seeing that? I got one more term to go there. But does everybody see how I got that 3 halves x? You guys getting that okay?
How did you get the 1x third?
Get the what's that?
The 1x third.
Yeah, so this is minus a half. He's going to each of them. So minus a half times 2. What's half of 2? 1. Good to there? Half of 2 is 1. X cubed, right? And then half of 4, do the next one. Half of 4 is 2, and it's 2 negatives, so it makes positive 2. X squared. Good. And now when I do half of 3, I did it right over here for you. So half of 3, it's negative a half times 3x. Put that 3x, remember, whenever a whole number is interacting with a fraction, you put it over 1 to make it look like a fraction. So I took that negative a half and that positive 3x, I brought it over here, negative half times positive, put it over 1, and then go top times top, 1 times 3 is 3, bottom times bottom, 2 times 1 is 2. So in other words, it's 3 halves, right? Because the 2 goes to the bottom, the 3 stays on the top.
Why wouldn't it be 1.5?
They don't want decimals. It is 1.5, but you can see all the multiple choice answers are fractions. So we have to go with fractions. But you're right, it is 1.5. But one more to go. Is that making sense? Last is the minus a half times minus 2/3, right? Minus a half and minus 2/3. What happens there? 2's cancel. 2 negatives makes positive 1/3. Is that good to there? We're not quite done. This is a long one. So now we're in adding, subtracting mode, right? Multiplying's over, no more parentheses. Now combine like terms. So 2x to the 4th, he's in a class by himself. Minus 4x cubed plus, or minus 1 other x cubed is minus 5x cubed. Good so far? Plus 3x squared plus 2x squared is 5x squared. Now for the tricky one. Minus 2/3 x minus 3/2 x. That's a big pain. This is a hard one. Minus 2/3 x minus 3/2 x. How am I going to subtract or combine by adding, subtracting those two fractions? You got to get a common denominator. This is where it's nice to have a Casio natural display and just enter it. So yeah, you got to multiply top and bottom of this guy by 2, the other guy by 3. Remember, you multiply by the other guy's denominator, right? So I get minus 4/6x minus 9/6x, which is minus 13/6x, isn't it? See that? Everybody tracking? That's a little messy. Lastly, plus the 1/3. There it is. Hopefully that's one of those 4 options there. I can't even see them anymore, but anyway. Is that good? So that's messy. That's the worst of them right there. Okay, I'm going to flash that off. If you didn't get it all done, it'll be on. Okay, so these will be the same thing. They'll just be easy versions. So x plus 7, x minus 7. You want to do that one? That we've already done, huh? It's just going to come out super clean. They want you to see the pattern. So go ahead, just do the normal thing. Nothing new, no new rules at all in this section. Same thing we were already doing. So the first one goes to both. X squared minus 7x. And then the second one goes to both. Plus 7x minus 49. We good to there so far? First to both, second to both. Now, when it comes time for combine, now we're in adding, subtracting mode. The parentheses are gone, multiplying's over. What's going to happen in adding, subtracting mode? What are the middle 2 terms going to do? Yeah, they're going to minus 7 plus 7 is 0, huh? So it's just going to be x squared minus 49. So that wasn't hard, or it wasn't as hard as those last ones, even close, huh? So this section's easier, but what it is, if you click on the show me an example button, what they'll say is they'll go, hey, they'll say, look, if you've got the same 2 things, that's what they're going to do. They're just going to keep giving you ones just like this that have the same 2 things. See how it's not like a 7 and an 8 or something. It's a 7 and a 7. 1 plus, 1 minus. They're going to give you a whole bunch in a row where you have the same 2 numbers, one with a plus, one with a minus. And they're going to go, look, if you want to, you can skip all these steps and jump right to the answer, because it's just going to be that front number squared, that back number, 7 squared 49, with a minus, because it's 1 plus times 1 minus. Sure, yeah, they're right. I'm not going to write any more snazzy rules. I'm just going to do it, and it'll be fun. But if you want to like learn their rule and click on their help button, they're right. You could just jump to the answer. But that's why they're giving you these, because they're wanting you to observe. Oh, look, you can just write it out quick. And if you want to, that's fine. I'm going to just do the same thing I've always done, and just go first to both, second to both. So, okay, so 2t minus 4, 2t plus 4. So if you want to do their tricky rule, you could jump right to the answer. Or you could just do it the regular way we've been doing it. First to both, second to both. So the first to both. So I'm just going to do it the same old way as normal. So remember, when we multiply, what do? Out front numbers multiply, powers add. What would powers? There's understood 1 powers, huh? So 2t is 4t squared plus 8t. He's done. And then the minus 4 will go to both. Minus 8t minus 16. Yeah, same thing. Boom, boom. The middles cancel. 4t squared minus 16. So they're right. I could have just skipped that and just multiplied the first 2 and the back 2 and put a minus in the middle. It'll always happen that way. So they're just showing you, hey, look at the pattern. We can do these quicker. That's why they're calling them special products. Their product means multiply. Special multiplications. But anyway, you don't need to do anything different. Just do what we've been doing all along. They're even easier, really, than the last section. So now they're going to put a 2 power. Okay, so a minus 3 halves squared. So I'm sure you know, what do we do when there's a 2 power on those parentheses? That 2 power means 2 of them. We actually write 2 parentheses like that. And then it's another one of the same things we've been doing. That's what a 2 power means on something, huh? It means 2 of them. So when it's on a parentheses, so go ahead and take it from there, do the same thing we've been doing. First to both, second to both. So we're going to get a, right, the 1 powers add. Understood 1 powers, the visible 1 powers. Minus 3 halves a, and then he's done. And then minus 3 halves a. And Nathan's thinking is positive 9/4. Did you guys get that okay? Multiplying's over. Now we're in adding, subtracting mode. Let me hold there for just a second. There's one more step. But are you okay to there? Does that make sense what happened? So the a went to both, and then the minus 3 halves went to the a, and then negative times negative is positive. 3 halves times 3 halves. Everybody see what happened there? Negative 3 halves times negative 3 halves is positive 9/4. Right? 3 times 3 and 2 times 2. It's times. Question, James?
Minus
Oh yeah, we have another step to go. Yeah, we have to do something with those. Everybody good so far, though? Is it all okay so far? Now, yeah, we have to do something. What are these guys going to do? We're in adding, subtracting mode now. Well, what's the story with fractions? You can combine fractions when they have the same denominator, and they do. So combine them. It's minus 6/2, isn't it? Which is negative 3. It's going to be minus 3a in the middle. And there's our answer. Does that make sense what happened? When we were in adding, subtracting, minus 3/2 and minus 3. Remember, you just do the numbers in the top. You don't mess. Once you get a common denominator, you just keep it, right? So it's minus 3 and minus 3 is minus 6. Divided by 2 is just minus 3. So the middle is made minus 3a.
Why isn't it negative and positive?
That's when you multiply or divide. Yeah, so really important you get that distinction straight. Yeah, when do two negatives make a positive? Always?
Always.
Not
Multiply,
always.
multiply.
Only multiply and
Or
divide.
divide it.
Yeah, but adding, subtracting, they don't do that. Good question. Good clarification.
Negative minus a negative is just more negative.
Yeah, right. Because it's like money or something. If you have a negative on your bank account and another negative, that's not positive. That's just really negative. Yeah, I've experienced that. Yes. All right, so we finished.